Hello everyone. In our journey creating this game, a next step would be actually to enable for a user to control this ball. And for this purposes, we will create two different how do you call a ball control inputs. One will be controlling with a mouse, so we can control it in our editor. And this allows us to do follow-up testings, etc., etc. And the second input type would be Android, the platform we're creating for. Of course, we'll create the third one and the fourth one if we're looking for iPhone or tablets, etc., etc. But at the moment, we'll just concentrate on two of them, PC and Android. So let's start with PC one. At the beginning, we'll create a script. We will call a gravity input PC. And of course, while we're here, we can create a second one, a gravity input Android. Okay, nice. Okay, I don't want to mix up about. We have other option. We can create only one script, and in the script we can define saying if it's an Android or if it's an editor you do this, and if it's a Android you do that. The difference why I want to keep this script separate and not actually defining, one thing is just for simplicity, and the second thing, you will see that it kind of different, how to say, it's a different approach to physics. We need to actually write a separate code in update, and separate even variables must be a different. So how much force we're adding in the phone taking gyroscope, and how much force we're adding taking input as a mouse, it's a different approaches. So for simplicity, it's much easier just keep this both scripts as a separate, and you just apply depending which platform you're using it. Okay, yeah, I said let's start with the inputs in PC. Okay, let's clear a few things. At the beginning, we need of course we need a game object of ball. Then we need a rigid body 2D of a ball, so I call a rig ball. Rig ball. And we need, what else we need? Yes, we need a platform manager. Platform manager, and we call platform MNGR. And the reason of this, I'll make a note here, to access platform manager to trigger a point counter. Okay, so we need to know when the ball hits. When the ball hits a certain platform, we say, oh, you know what, you hit it, what's it called? You hit the platform, so it's no more 3 points, it's only 2 points. You say hit a second time, and again, you earning 1 point only. We need a public float where we identify max speed. And I find that 2 floating and 2 float is very good at a very good speed. This is a variable where define a maximum speed ball can reach. Max speed. And the reason is because we will be keep adding some force. Taking account that we adding force by leaning phone or by moving the mouse. In addition, we have some bouncing force. So if we if we adding everything in the same what's it called, in the same if we add everything on the same rigid body, this, you will see that the ball can actually reach incredible massive speeds, and our even physics engine can start breaking down, and the ball start flying through the platforms or through the walls just because the ball is going, I don't know, nearly light speeds, etc. Okay, well, not close light speed, but you get the idea. Okay, we can no, we don't need this one. Oh yeah, we definitely need this. A vector 2 is our force. So we want to track we don't want to track our force, so we can actually compare with our maximum speed, and if that is over our maximum speed, we just, you know, what's it called, we do some actions. Okay, thinking out loud now what we need. Okay, so we're dealing with PC now here. Two things what we want to do. First, we need to take input from a mouse. And also, we don't want to allow the mouse to go outside of our screen. So cursor lock state, cursor locked is one thing. So here, in this state, our mouse will be locked in the middle of the screen. You will be moving the mouse, but mouse is locked in the screen, and you just reading your what's it called? You're just reading your input from a mouse. It's good for a shooting game. Also, it should be followed by some hide. Also, you know, like hide mouse. Just guys, hide mouse. So if you lock your screen and you hide if you lock your mouse and you hide your mouse, suddenly you can just take input from a mouse and you can't see your cursor. But for this one, it's not good, because if you move your mouse in this area, if you locked in the center of your mouse, you don't know how much of your mouse is in the left or how much of your mouse is right. So if I want a ball just go straight line, I can't say how much force I'm adding because I don't have visual reference of a mouse position. So this lock doesn't work for us. And good one is confined. And what confined does, if I do this and nothing else, just do this, gravity input PC, what you will see, if we go back, yeah, and let's get our manager and add gravity input PC. And if I play, so if I play, yes, you see, my mouse cannot leave anymore the game screen. Put this way, that's it. I can't go out. So now I can go from here up to here, left and right, and up and down is ignored. We just will care X position within screen. Okay. By the way, to free your mouse again, you need to press escape button. Okay. Now we want to do we want to get our ridge ball. Ridge ball is equal to ball dot get component. Don't forget to put ball. Don't put just this. Get component rigid ball. No, you need to ball dot get dot. Difference, if you don't put the ball dot get component and you just say get component, that means you're referencing to this manager. If you don't define the game object you're trying to get your rigid body, it will be a game object where the script is added to. So in this case, if I delete this one, it will get component rigid body from a manager, this game object. And apparently this game object does not have a rigid body, so it will be null reference. If we define which game object, in our case ball, we have a rigid body 2D. So that's why we put ball.getComponent. And of course, it's a platform manager. In this case, we don't need a ball. We need to just say get component. And this is a good example, because now you can see that I'm trying to get a platform script of platform manager script from the same object, game object, where the script is added. So Gravity PC is here, and I'm trying to get this script. And by looking at it, yes, we're doing this one. We don't need to say manager or something like this. Yeah, we just get component. Okay. Now we can say inputs. Oh yeah, we forgot about this one. Main float input and number the number containing our input from mouse in x-axis. So it will be, and what we try to do is from, I believe we try to get from -1 to 1. So if our mouse is the left side, it's -1, and if it's in the right side, it's +1, and in the middle will be 0. Okay. Okay. So our input is equal to, and yes. So we cannot go this. We can go this one. Input dot mouse position dot x. That's straightforward. And to showcase what we got here, debug dot log mouse. Oh, sorry. Mouse input is, and we just add input. Yeah. What it does, it will print mouse input is space, and will be this float number. If we run the game, I'll just try to open console for you guys. Yeah, that's a console for you. Yes, you can see that my mouse is 1072 on this side, and close to 0 on this side. And if I go, yeah, it's still close to 0 on this corner, and 1000. So what are we receiving here? We're receiving where our mouse is within game screen, or sorry, not game screen. How do you explain? Not game screen, a display, our phone display. So because the phone display, a resolution we define is here. It's 1080. Yes. So when I put it on the right side, it's 1080. On a different phone, it could be different value. Of course, this will be always 0, but it's not negative, you know. And this is really different what we want. We want from -1 to +1. And to do that, we need to take this position on the screen and convert into world position. To do that, Unity has really nice tool. We get camera.main. So we addressing to our main camera, which one is looking to our game, and that camera knows wherever every object is, so world position, and the same camera knows the screen and the mouse position. So this camera.main has ability to convert our mouse into world. Okay, and more to even complain more, if this ball is in our world position 0,0. So when I'm moving my mouse and holding here, it should be 0,0 also. To do that, camera main dot screen point screen. No, sorry, it's not point. Screen to world. Screen to world point. Okay, so screen to world point is my mouse is on the screen where that point is in the world. That easy. To do that one, we need a new vector. Okay, so a vector must be Yeah, a vector must be where on the screen your mouse is. Yeah, and as we saw already, input mouse does have this ability. The key is that what we do here also, the trick, we don't care about X or Z. Sorry, we don't care about Y and Z, we just care about X. So we create new vector 3, which we need to put our mouse position. And we put mouse position.x, comma. We could put mouse position Y and mouse position Z if we need. Well, Z doesn't exist in 2D plane in our display, but we don't care about Y. We don't care where the mouse is up and down. What we care is how left and right it goes. So what we do is put 0, comma, 0 and silicon in the end, and we delete this one. So now we're getting problem if you hover your mouse. It says we can't change between vector 3 and the float. Cameras.main.screen to world point returns a position in the world as a vector 3. So if I'm holding mouse somewhere here, it goes and returns this point in the world and as a vector 3, x, y, z. Again, we need as input just a one number. So what do? We put .x. We just care about .x. If we care about up and down, we put y. And if we care about z, if we go up and down, but I don't know how that works. It's also be 0. But you get a picture here. We care only left and right. If we put input x and input y, we can do this one and we just change this one in the end of y. If we for some reason your game needs up and down. And because our final game will be taking gyroscope, that means you can actually take your Y position also. Let's say you have this game where you have like a table and you have a hole and you have a ball somehow to wiggle between all the dangerous things into that the hole, and you need to avoid all the I don't know, some other holes where you lose points, etc., etc. So that in that case you'll take X and Y. For us is only this. And actually let's save it and let's run it to see input. Take attention in the corner here. So we have negative 2.0 and positive 2.0. Okay. Negative, positive. Negative, positive. Okay. So what still it's not -1 and +1. And because it's really simple. Our world is scaling depending display size. And we know on 1080 by default it will be 2.0 side and 2.0 another side. To get it normalized on another language, to get it between -1 and +1, what we need to do is just literally divide by camera. Oh yeah, no, platform manager dot camera. Yeah, camera max dot x. So if we know what size of camera x is, and our input by dividing it. Cancel. Sorry. Yeah. Wrong button. Wrong play button. Okay, so we had some error. I just checked behind recording. So we're trying to get divided by platform manager dot a camera. So you already write this one previously. So the problem is that at the start we're executing line by line, and we've done this. We're confining this one. We're getting reachable. We should get a rigid body too, but what we never did is the ball, what we're trying to reference, we never dragged in one. We never done this action, dragging ball into a script. And because script is failing on line 19, it never executed line 20. And because we never executed line 20, here when we're trying to do camera input, we failing it, saying like I never seen this before. So, but because we just dragging ball into gravity input PC script, should sort it out. So again, let's hit play. Take a, now you can see it's a almost -1. This fraction 0.0018 I think is missing. I think it's like a pixel or something like this. And another side it's 0.0009, so it's even less. So it's almost perfect one. And almost perfect one in this scenario is very great because it is just a few pixels of cursor, which one is not allowing you to go to this one. Okay, so now we got this. Now we have our input between -1 and +1. Yeah, and we just comment out this one, and we just put in the end. So now we need to do our force. So force is equal. So new vector 2. Yeah, and it will be a force we adding up. So to explain it more, ball has force dot x. Yeah, because we're adding just nx. We don't care about gravity. Gravity is dealt by physics. So ball has this one. So what we do will be has ball dot force dot x. What we want to do, we adding fraction of force dot x. Ball already have this one, which one could be maybe around could be maybe 6, and we will be adding some like I don't know, 0.01 maybe, you know, a force. So ball for force x could be already +6 is really fast going this one, and we keep adding even more, 0.1. So this is how it works. So force is just a fraction we keep adding on the top. So like we done before, I'll just copy it. Inputs divided by input divided by camera.x. So we know this. Multiply, I find this number. This number you need to dial up. This number you need to adjust what you think for your game is the best to look more realistic, or maybe even give a bit like a flavor for your game. I find that 3000 it is most realistic one, and that times delta time, and for vector 2 we need to give a y, and y is 0. We're just adding x. And now what we do is really simple. Ridge ball dot add force, and we just add force. That's it. Yes, ridge ball, just add the force, because we're not adding anything on a 0. 0 is dealt by bouncing, and it's dealt by what's it called, gravity. We're just only adding some input from a mouse on the x-axis, so we just controlling left and right. Okay, well, now it's clear down all this. Okay, save. Let's test it out. We have not done yet speed checking anything, so you can see it is mega speed. Wow, it's very sensitive. Looks like 3000 was way too much, actually. I can tell that. And it's normally because it's a one thing is you want to add very sharp control. Again, you can deal all that numbers. Oh, see the X force is so great, even the ball bouncing in the wall start going up or down. And I'm just barely moving the mouse. Jesus Christ. Okay, let's add this. Let's add a thing about. Let's create a new function called void check speed. And it is a reason why you want a very sharp, very high force number. And the reason is that you want to be able to change direction of your ball instantly in mid-air. So you have some control. You wanna, if a ball goes left, you want to move your mouse right and instantly change. But you don't want it to give this incredible speeds. You just want it to give a high force number, which allows you to turn. Okay, and a check speed, we just say very simple. If reach ball dot velocity dot x is greater than max speed, we want to say at reach ball dot velocity is equal to new vector 3, and we want to give a max speed, so we reset back to 1. So if x is greater than 2, we say, okay, now your velocity is back to 2. So it's if it's 2.1, then you back to 2. And reach ball velocity dot y, we're not touching whatever it was y, we keep it y as it was. Let's say the ball was falling or the ball was jumping by velocity of 3. You stay free as it was before. We're just resetting x. And of course, we know that z always will be 0. And again, I'm repeating, it's really good mana. Even though we're creating 2D game, just keep it in vectors phrase. And yes, it's a bit more. Yes, it could be a bit. You can complain saying it's a bit more space in the memory, creating a necessary larger variable type, a vector 3 comparing the vector 2. Sorry, but it's so minor change in current technologies. It is not a problem at all. It's just getting you used to vector 3s. It's a good skill when you climb to the more interesting games, and you're not getting mixed up between vector 2 and vector 3. And again, it just, if me personally, maybe I'll do with vector 2s because I've been already in that problem where I started coding. I started with vector 2s, and so in other places you need vector 3s, like etc. Screen World gives you vector 3, even though your game is vector 2D and you can't do anything about it. If this function returns vector 3, and later on you're doing more interesting game or more advanced game with vector 3s, and you first time seeing z's, and you're trying to do everything in vector 2s. No, very simple. As a beginner, intermediate, etc. Just do vector 3s. It doesn't hurt. Really simple, and you get to use to very good skill. Also, let's carry on back here. So next one will be else if, and we wanted to do else if because really simple. Our ball, if this is a true, we don't need to do a second reach ball dot velocity dot x is lower than minus max speed. It is, if this becomes true, you don't need to check this, because our ball cannot be same time higher and lower. That saves as a reach ball dot velocity is equal to new vector 3 minus max speed. And don't forget minus max speed, not positive this time. Again, we're not touching velocity at y-axis, and z will be 0. Okay, and that's it. We just need to call in update now. After we apply our force, we want, say, a rigid check speed. After we apply some force, please adjust it. And in that case, let's save it game. Yeah, and in this case, we should, yeah. Easy to do with mouse. Looks like bouncing is really... Oh, bouncing is... What's a bouncing is set up to? So just quick reminder, going project in assets, we have this bouncing material created. Friction is 0.4 and the bouncing is 0.8. And the ball mass is 1 and the gravity scale is 1. Okay, it didn't felt me like bouncing enough. Let's increase like 0.9. Somewhere between these lines. It's a bit... It feels like we applying force and we doing something with y. Okay, let's try to turn off gravity input PC, and we lose now controlling the ball. But what we want to see how the ball is then jumping. We just allow a bit more to go up. Because we don't have a losing game condition, we allow it to just go up. Now 0.8 is correct. 0.8 is correct, the bounciness. And the main reason is when the ball bounces on one platform, you don't want it to allow the ball to bounce so much up, back to one level up. If you go below one level, the bounciness should not bounce you back so much. You're going up back to a level. Makes sense. If rigid ball velocity x is greater, new vector rigid ball velocity y, and velocity y, whatever it is, you go back. And yeah. Let's try to minimize a bit this one for 800s. Maybe just me today. Too picky. Oh, we forgot to enable script. Okay. Now it definitely looks like it's like a metal. No bouncing at all. And if we do again, but not moving mouse, yeah, looks like first one is good. The second and okay, yeah, it's maybe me. Oh, we don't have this. Yes, I know. We don't have developed yet a bounciness after the ball drops, is it? I don't think so. Yes, it's nice in this scenario, but we don't have this. Okay, yeah. So I know what's a problem. It's not a problem. We have not yet developed a after the ball dropping down from the holes and we have speed up. The first platform coming in at contact with the ball must generate a velocity back to it, and that must be done manually via script, not via physics engines. That's why we have this really weak bounciness happening between platform and a ball in the very bottom of our display. But let's do one step at a time, and we'll sort it out everything. Okay, so we just done this on a PC. Let's do same on Android. And I don't want it to go this lesson very long, but after we do this step, I'll leave it to the next lesson, next video, where we actually deploy this and we test this on a phone itself. Okay, so let's speed things up. So we know, we are ready now, but we need a public game object ball. Yeah, we know that we need a rigid body, which one we call a rig ball, and this is a different one. We need a gyroscope, and we call it gyro. Then we need a bool, gyro axis. So it could different phones with different versions of Android, especially with iPhone, you need to request access to confirm from a user that they allowing this application to use a gyroscope within phone. Okay. Then we need the same public what's it called, float max speed, and we do same to 2f. Okay, and yeah, vector 2 force. Okay, at the starter, we start asking if system info dot supports. Ooh, that's a lot. Supports gyroscope. Yeah. So we're saying gyro axis is equal true. So in this case, we just literally testing if a gyro axis is true. If not, we're not doing anything in the script. And it's a reason because the person didn't allow it yet to use it because he pressed don't allow, or maybe or maybe device doesn't even have a gyroscope. So this game is not playable on that device. I'm not sure any device at given day does not have this gyroscope inside in any condition, because most devices today can rotate your screen sideways, landscape from portrait. But if this is still good manner to test it. Okay, else. We're saying gyro axis is false. Okay. Now we're saying if gyro axis, and again I don't need to say if gyro axis is equal true, because gyro axis is a Boolean, so it is a true or false. So if true, gyro axis, so it's just cutting corner. If you don't feel very confident, I remember at the beginning I always do this. I used to do this. I have gyro axis is equal true or false, but actually you just if gyro axis. That's it. It is himself. It's a Boolean true or false. So gyro is equal to input dot gyro. So now we have reference of our gyroscope, and another thing what we need to do is to gyro dot enable. And this is a crucial point. I saw some tutorials or some forums that people actually forgetting to enable gyroscope, and they do everything. We're getting access, and we do input gyroscope, and we receiving zeros. And it just the main thing is in Android, if you don't enabling a gyroscope gyroscope is actually not communicating with your application. And I'm not sure if gyroscope is not active. I know that it's not communicating and your values is always 0. Okay. About other things what we need to do is again rigid ball to get component. Again, it's not game manager. We need to rigid ball. We need to get ball dot get component rigid ball rigid body. And other really cool thing is application dot target frame equal 240. And you say, whoa, that's 240. The best, what's it? Not the best, but how to say, most common top level, top quality, phones are like 120 frames per second, and only few gaming phones are actually running more than that. And the reason is really simple. We're hitting 240 in our application, and it will be limited to the maximum frame the phone can do. You can do 200. You can do just 120, be safe. But if someone playing this game on this gaming phone, or I don't know, by next year, that 240 will be standard in iPhones and the Androids. Like I don't know, 120 frames per second in S22 Ultra. It is running. The thing is, what you want to do is to set a max. You need to overset this number, like 240, and the application or the operation system will limit down to the maximum it can handle. You don't want it to do 60, or you don't, or if you don't do this line at all, it will be run by default at 30 frames per second, even though your phone can do 120. Safe call would be just overestimated, and allow the system to say, we can run this one, we'll do only 120, 90, 60, or whatever your phone can handle it. Okay, in update, really very similar. The thing is, what we want to do here different is about this gyro. If gyro access, if no exclamation in the beginning, if no gyro access, so you put exclamation in the beginning, what to do, you just do return. And I'm not sure if I explained it before, if the code hits this return, nothing below this point will be executed. Yeah. So if we hit this return, nothing below, wherever we write, it will be never hit it. And this is happening because if no gyro access, please return. And the main reason is if you don't have a gyroscoping device, we not even need to bother to do anything below here. Okay, and this is really simple. Similar what we've done before. So force will be equal to, and the same. New new vector 2, and this time we don't have a camera to translate our mouse. What we need to do is to actually take our what's it called, our gravity, and if we look here, we need to take the input from the gyroscope, and depending how much you're tilting left or right, yes, and depending how much you're tilting left and right, you need to get between -1 and +1. And actually, it does this way. We will be next video when we connect to our phone. I'll showcase how to receive some logs from device at runtime, and we can actually see how much of how the gyroscope reacts to your rotations, and you'll see really cool stuff actually here. So if you're thinking in gyro dot, you need to attitude, orientation space, actually not. The correct variable we need to get is gravity. .x for x and 0 for y. We don't care about how you're rotating in y, unless you're making full table game. And the thing is that the people, what are we getting? How is it? We get stuck into I don't know. The people getting stuck using gyroscopes is because mainly they're using attitude. And attitude, by this reading your by reading your description of this variable, it returns quaternions, and quaternions is one of very advanced, not very advanced. It's more advanced and more precise rotation identification compared with vector 3, and it has really I would say it is much better way to describe how the object is rotated compared with vector 3. But it is also overkill and even involves too much problem in this attitude, because it gives orientation in space, including rotation to north, south, west, or east. And I played with this number. I was thinking, guys, maybe it's a really good opportunity to showcase you quaternions. But it's really strange how it reacts when person is rotating phone when he's facing north, and suddenly he turns into the west and start rotating the phone, and the value it returns back. It's totally different. It's good, but it's necessary mathematical calculations need to do just to get how much the phone is rotated in x-axis in the relation to the earth or floor. Put it this way, yeah, we don't care if it's north, east, or south. We just care to the gravity, So that's why we need to use a gravity .x and 0 at this one. And again, what we do is ridgeball dot add force. Instead of adding force directly, we would add force here directly. But what we need to do here, the force, when we get input, we need to do a few magic things. We need to, first of all, multiply again by 3000 and multiply by time. Oh, we can't. Sorry. We can't multiply all vector 2. What we can do is multiply only x. Time 3000 and time delta time. Yeah. So force is equal new vector 2. We're taking gravity x, multiplying by 3000 and multiplying by time delta time. And it's 0. So we don't care about gravity dot y. And we're adding it. Same again, we need to create a new function, which one called check speed. And I just literally copy. Let's go back to our PC and just literally copy this one. Copy and paste. And if I'm not mistaken, it should not be any problems. Okay. Check speed, okay. And that's done. If you know already how to deploy this on your phone, you are more than welcome to do it. Just before doing this one, add a script of Android to the manager and turn off input for PC, leaving only gravity input from Android. And you can deploy. I just don't think this lesson is already taking long just for a really simple input. Let's keep it shorter videos, and I'll see you in the next video, where we actually will deploy this Android input script and we'll test it on a phone. Thanks for watching, and talk to you soon. Bye. And